Hi friends, today we will discuss about solution of initial value problems. So before going to solve initial value problems, we must know what do you mean by initial value problem. It means a differential equation f of dy by dx xy equal to 0 with along with initial conditions y of x naught equal to y naught, y dash of x naught equal to y dash naught is called initial value problem. Initial, in short, IVP, initial. For example, d square y by dx square plus 2 dy by dx plus y equal to 0 with y of 0 equal to 0, y dash of 0 equal to 15. This is the example for initial value problem. So now let us solve one initial value problem. So the question is, solve d square x by dt square plus 5 dx by dt plus 6x equal to 0 given that x of 0 equal to 0 comma dx by dt of 0 equal to 15. So in this problem, if you look at the differential equation, here the derivative is d by dt. So put the differential operator d by dt equal to capital D. If you substitute d by dt as capital D, we get, so d square by dt square, so d square x plus 5 dx plus 6x equal to 0. So here x is common, so if you take x common, it can be written as d square plus 5d plus 6 into x equal to 0. Here the dependent variable x is non-zero, so this implies this part is 0. So if you replace d by m, we get auxiliary equation m square plus 5m plus 6 equal to 0. So now it is a auxiliary equation. Here we need to find roots of this auxiliary equation. So quadratic equation, we need to think of factorizing this. So 6 can be written as 2 into 3. So multiply 6, 2 plus 3 is 5, middle term. So it can be written as m plus 2 into m plus 3 equal to 0. So product of two factors 0, this implies m plus 2 0, m plus 3 equal to 0. So m value, m equal to minus 2, m equal to minus 3. So total m values are minus 2 and minus 3. So now if you look at roots, these two roots are not equal. Minus 2 is not equal to minus 3. So therefore general solution y equal to c1 e raised to minus 2x plus c2 e raised to minus 3t. Sorry, this is d by dt, c1 e raised to minus 2t, c2 e raised to minus 3t. So now consider this as equation number 1. So now along with differential equation, we have initial conditions. Let us, two initial conditions are there. Let us apply one by one. First, let us apply x of 0 equal to 0. So given x of 0 equal to 0. So it means x 0 when t 0. So substitute in 1. From 1, in 1 if you substitute, so what we get? X 0, sorry, this is x 0 when t 0, c1 e raised to 0 plus c2 t 0 e raised to 0, g raised to 0. So it can be written as c1 plus c2 equal to 0. So this is one equation we got here. Take this as equation number 1. Now let us go for second condition, dx by dt of 0 equal to 15. So first we require dx by dt. Here in equation we have x in terms of t. So differentiate 1 with respect to t, we get dx by dt. So differentiate 1 with respect to t. So dx by dt equal to c1 e raised to minus 2t, c1 e raised to minus 2t differentiation e raised to minus 2t into minus 2 plus c2 e raised to minus 3t differentiation e raised to minus 3t into minus 3. So now we got dx by dt. Let us apply given condition. Given dx by dt of 0 equal to 15. So this means dx by dt is 15 when t is 0. So substitute here, dx by dt is 15 when t 0. c1 e raised to 0 is 1. So c1 into minus 2 plus c2 e raised to 0 is 1. So into minus 3. So we get minus 2 c1 minus 3 c2 equal to 15. So now if you look at equation 1 from 1 c1 plus c2 is 0. So c2 is minus c1. So substitute here, minus 2 c1 minus 3 into c2 is minus c1. So minus 3 into minus c1 plus 3 c1 minus 2 c2, which will be c1 value 15. Similarly, we know that c2 is minus c1, c2 is minus c1, so minus 15, c2 is minus 15. So now substitute in equation 1 from 1. So if you consider from 1 x equal to c1 is 15, c2 minus 15. Substitute here, 15 e raised to minus 2t minus 15 e raised to minus 3t. So here common is 15. So if you take outside 15 into bracket e raised to minus 2t minus e raised to minus 3t. So this is the final answer, which is also called as particular solution. Let us solve another example of initial value problem. The question is like this: solve d square x by dt square minus 4 dx by dt plus 13x equal to 0. Given that x of 0 is equal to dx by dt of 0 is equal to 2. It means x of 0 is 2, dx by dt of 0 is also 2. So now to solve this problem, here you look at the derivative dx by dt. It means the dependent variable is x, it is dependent on independent variable t. It means x is function of t, x is in terms of t. Now here the derivative is d by dt. So put d by dt that is equal to capital D. So if you substitute d by dt equal to capital D, what we get? D square by dt square means capital D square x minus 4 capital dx plus 13x, that is equal to 0. So throughout x is common. So if you take x common, we can write it as d square minus 4d plus 13 into x equal to 0. So here the product 0 and x independent variable x is not non-zero term. So this implies auxiliary equation can be written as m square replace d by m square minus 4m plus 13 equal to 0. So if you look at this equation, here it is a quadratic equation which has to be solved. But now let us go for factorization. 13 is a prime number whose factors are 1 and 13. So when you multiply it will be 13, when you add it will be 14, but here it is minus 4. So factorization is not possible here. So then you need to go for applying the formula Sridhar's rule. So what is that Sridhar's rule? Ax square plus bx plus c, ax square plus bx plus c equal to 0 is a quadratic equation. Then x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So let us apply this result. So if you look at ax square, a is 1 B minus 4, C 13. So apply the formula m equal to minus b minus of minus 4 plus 4 plus or minus square root of b square minus 4 square 16 minus 4 AC 4 into 1 into 13. So 4 into 13 is 52 divided by 2a, 2 into 1 which is 2. So now let us simplify. 4 plus or minus square root of 16 minus 52 which is minus 36 divided by 2. So now 4 plus or minus, so square root of minus 36 can be written as square root of minus 1 square root of 36 divided by 2. 4 plus or minus square root of minus 1 is I, square root of 36 6 divided by 2. So 4 by 2 which is 2 plus or minus 6i by 2 is 3i. So the roots are 2 plus or minus 3i. So it is of the form alpha plus I beta form, alpha plus or minus I beta. So alpha is 2, beta is 3. So the solution, general solution is, so here dx by dt, x equal to e raised to alpha t 2t e raised to 2t into bracket c1 cos beta t 3t plus c2 sin 3t. So this is the general solution. So take this as equation number 1. So now what we need to do is, we got general solution, but along with this initial value problem, along with differential equation, we have initial conditions. So let us apply one by one. So first condition, x of 0 equal to 2. So given x of 0 equal to 2, though it means x equal to 2 at t equal to 0. So apply this condition in equation number 1. So from 1, so x equal to 2 when t0 e raised to 0 which is 1 into bracket c1 cos 3t cos t0, so cos 0 is 1, so c1 plus c2 sin 0 0 into 0. So it is c1 equal to 2. We got c1 equal to 2. Now we applied first condition, but we need to go for another condition which has been given, dx by dt of 0 equal to 2. So here to apply this condition we need dx by dt term. So whatever the equation 1 x we have, differentiate that with respect to t, we get dx by dt. So differentiate 1 with respect to t, So if you differentiate x dx by dt, that is equal to e raised to product. If you look at this product of two terms, we know the product rule, u into v dash is u into v dash plus u dash into v. So apply that result, u e raised to 2t into v dash, derivative of second term, so c1 cos 3t differentiation minus 3 sin 3t plus c2 sin 3t differentiation 3 cos 3t plus next u dash into v, e raised to 2t differentiation 2 e raised to 2t into bracket into v, c1 cos 3t plus c2 sin 3t. So now we got dx by dt. Let us apply second condition, given that is given thing is given dx by dt of 0 equal to 2. So it means dx by dt is 2 when x is 0. So apply this one, dx by dt is 2 when t0, substitute t0 e raised to 0 e raised to 0 into bracket c1 sine 0 t0 cos 0 is 1, so 3 c2 we get, plus 2 into e raised to 0 is 1 into bracket c1 cos 3t cos 0 c1 plus c2 sine 0 is 0, so that term becomes 0. So we get 3c2 plus 2c1 equal to 2. But we know c1 value is 2. Substitute here, 2 into 2, 4, 3c2 plus 4 equal to 2. So if you transfer this side, we get 3c2 equal to 2 minus 4 minus 2, so c2 is minus 2 by 3. So now we got both constant, arbitrary constant, c1 equal to 2 and c2 equal to minus 2 by 3. So both you substitute in the given equation number 1. From 1 x equal to e raised to 2t into bracket c1 which is 2 cos 3t minus c2 is minus 2 by 3 sine 3t. So this is the solution of given initial value problem. Now let us solve another initial value problem. The question is like this: solve y double dash minus 2y dash plus 5y equal to 0 given that y of 0 equal to minus 3 comma y dash of 0 equal to 1. So before going to this problem, first solve the differential equation. Whatever the solution we get, in the on that solution you need to apply these two initial conditions. So now y double dash means d square y minus 2, y dash means dy plus 5y equal to 0. So here throughout y is common, so if you take y common, d square minus 2d plus 5 into y equal to 0. So here we have product of these two 0, but we know y term, this part is non-zero, so this implies this part is 0. So we get auxiliary equation where replace d by m. So m square minus 2m plus 5 equal to 0, which is a m square minus 2m plus 5 equal to 0, which is a quadratic equation. To solve quadratic equation, we have two options. We need to go for factorization or formula. First, let us think of factorization. 5 can be factorized as 5 into 1, but when you multiply it will be 5, when you add it will be 6, but here it is minus 2. So factorization is not possible for this problem. Then you go for applying the formula. So we know this Rither's formula: whenever ax square plus bx plus c equal to 0 is a quadratic equation, then the solution root x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So here what we need to do is identify, for this quadratic equation, identify a, b, c and substitute in the formula. So m square coefficient is a is 1, m coefficient is b which is minus 2, constant term is 5. So now, so root m equal to minus b minus of minus 2 plus or minus square root of b square minus 2 square b square 4 minus 4ac, 4 into 1 into 5 which is 20 divided by 2a, 2 into 1 2. Now 2 plus or minus square root of 4 minus 20 is minus 16, square root of minus 16 divided by 2. Now 2 plus or minus square root of minus 16 can be written as square root of minus 1 square root of 16 divided by 2, which is 2 plus or minus I into 4 divided by 2, or it can be written as 2 by 2 1 plus or minus 2i. So it can be considered as alpha plus or minus I beta, where alpha is 1 and beta is 2. So now general solution y equal to e raised to alpha x e raised to 1x into bracket c1 cos beta x 2x plus c2 sin 2x. So this is the solution, general solution of given problem. Now, but along with this, in this problem, along with differential equation, we have initial conditions. So let us apply one by one initial conditions on given general solution. So here first apply first condition, y of 0 equal to 3. So given y of 0 equal to minus 3, so it means y equal to minus 3 when x equal to 0. So apply this one from one given equation from 1. Now y is minus 3 when x 0 e raised to 0 into bracket c1 cos 0 is 1 c1 plus c2 sin 0 0. So we get c1 equal to minus 3. C1 value is minus 3. Now apply another condition, which is y dash of 0 equal to 3. So y dash, we need y dash to apply this condition. So that's why differentiate 1, that is y, with respect to x, you will get y dash. So differentiate 1 with respect to x. So when you differentiate, y becomes y dash, and here product of two terms, e raised to x into another expression. So product rule you need to apply. So we know product rule, u into v dash is u into v dash plus u dash into v. So u e raised to x into bracket v dash, derivative of this part, c1 cos 2x differentiation minus 2 sin 2x plus c2 sin 2x differentiation 2 cos 2x plus u dash e raised to x differentiation e raised to x into v. V means as it is this expression, c1 cos 2x plus c2 sin 2x. So now whatever the y dash we got, on which apply the given condition. So given y dash of 0 equal to 1, so it means y dash is 1 when x equal to 0. So apply this condition, y dash is 1 x 0, substitute x 0 e raised to 0, which is 1 into bracket c1 sin 2x sin 0, which is 0, first term 0, plus 2c2 into cos 0 is 1, so 2c2 plus e raised to 0, which is 1 into bracket c1 cos 2x c1 into cos 0 1 plus c2 sin 0 is 0. So here we get 2c2 plus c1 equal to 1. But we know c1 value is minus 3. Substitute here. 2c2 equal to, so 2c2 minus 3, that is equal to 1. Minus 3 take this side, which will be plus 3. So 1 plus 3, which will be 4. 4 equal to 2c2. So c2 equal to 2. So now we got both values c1 and c2. So once you get this, substitute in equation 1. So from equation 1, y equal to e raised to x into bracket c1 cos 2x. c1 is minus 3 cos 2x plus c2, which is 2 sin 2x. So this is the final solution of given initial value problem.